Hello again. Let us continue with our analysis of loops in programming. But in this particular video, we shall analyze a repetition that is implemented using do-while construct. As usual, we have this worked example. The program looks more or less like the other two programs that we have been analyzing, except that the loop is implemented using the keyword do, which is culminating with a while closure and a condition that follows it. But then the instructions that are within this particular construct are two, that is n equals to n plus I and I equals to I plus 1. That is repetition. But as we can see is that do all this while I is less than 4. Now, the difference between do and while is that the do while will allow this particular condition to be done at least once before checking the control condition. It will allow repetition to take place before the condition is checked even once. So at least if the repetition, this particular set of instruction will have to be done at least once, it will be done even if the condition is not set. Now, but the program ends at these particular lines where we are going to have the output as usual. So the same program, if we wanted to look at it from the text, we can see now that this is where variables are declared, I and n is initialized, then the construct is set here, do all this which is enclosed in curly brackets, while I, which starts from 1, which will start from any value, from 1, will be checked against the integer 5, and once it is found that the value in I is less than 5, what is inside the do and while will be executed until this condition is not satisfied. In order to understand this particular scenario, let us check this program when it is in the compiler environment. This is the same code, int I, int n is assigned 1, do all what follows from do until I is less than 5. Now let us compile and then let us run. What we are getting is 11 and 5. It means in n there is 11 and in I the integer 5 is contained inside it. If we change here and we put the upper limit, let's say to 500, what will happen? It means this particular loop is going to repeat until I is equal to 500, then it will break and addition will be done onto n until this particular condition is fails to satisfy. Let us compile this program, and after compilation there is no error. Let us run it and we are getting this figure here, that is 124,751, while the limit of I is 500. Now, this is more or less analysis of these particular programs and repetition as far as analysis and dry running of text is concerned. What follows is the visualization of this particular program, analysis of its property using physical models, and then we'll use RAM diagrams. For now, I thank you and I would say bye-bye.